Hello and welcome. Today we are diving into a topic that plays a crucial role in ensuring the success of any business: quality control. Whether you're involved in manufacturing, service delivery, or even a small scale business, maintaining the quality in your products and processes is essential to staying competitive, satisfying customers, and reducing waste. But how do companies manage to keep their standards high? How do they identify and solve issues before they become major problems? That's where the seven basic quality control tools come into play. These tools, developed primarily in Japan after World War II, have revolutionized the way we approach process improvement. They are simple yet powerful, but make it possible for teams to identify the root causes of issues, analyze them, and create lasting solutions. Now, I know the idea of quality control tools might sound complex or even intimidating. However, the beauty of these tools is their simplicity. They are not just for engineers or data analysts. They can be applied by anyone who is involved in a process. Whether you're running a production line, managing a team, or even looking for ways to improve a small business, these tools will help you make more informed decisions and lead a better customs. In this video, we are going to break down each of the seven tools one by one, giving a real world example and to show how effective they can be. By the end, you have a solid understanding of how to use them in your own work. But before we dive into the details, let me just say that using these tools isn't just about adding complexity to your work. It's about gaining clarity. It's about finding smart, simple solutions that can save time, reduce costs, and boost your overall quality. So, whether you're new to quality management or just looking to refresh your knowledge, I invite you to stick around as we explore how the seven basic quality tools can make a significant difference in improving the efficiency and effectiveness of any process. Let's get started. Let's begin with the first one. Number one, Pareto diagram. The Pareto diagram is based on the principle that roughly 80% of problems come from 20% of the causes. This tool helps identify and prioritize those problems that create the biggest challenges in processes. The diagram consists of a bar chart that organizes the causes in order of importance, allowing the team to focus on solving the most critical issues first. For example, in a production line, if we identify the 80% of product defects come from a small group of causes, we can concentrate our effort on eliminating those few causes to significantly improve quality. Number two, check sheet. The check sheet is a simple but effective tool that helps collect data in a structured way. It is used to record the frequency of an event or defects in a process, enabling us to observe patterns or trends over time. Imagine we are analyzing how often errors occur in a certain stage of manufacturing. By using a check sheet, we can record and analyze these errors, making it easier to identify areas that require improvement. Ichikawa diagram or cause and effect diagram. The Ichikawa diagram, also known as the fishbowl diagram or cause and effect diagram, helps identify the root causes of a specific problem. It organizes possible causes into several categories, such as machinery, methods, personnel, materials, and environment. This tool is especially useful when investigating why a process isn't functioning properly. For instance, if we are experiencing a high defect rate in a product, we can use this diagram to visualize and analyze the possible causes from different perspectives, making it easier to make the right decision. Histogram. A histogram is a graphical representation of the distribution of data collected from a process. It allows us to visualize variability within the process and help us understand if that variability is within acceptable limits. If we are interested in knowing the distribution of production times for a batch of products, the histogram will show us how many products are made within each time range, allowing us to see whether most products are being produced within the expected time frame or if there is a lot of variation. Next is the scatter diagram. A scatter diagram is a tool to observe the relationship between two variables. It helps see if there is a correlation, whether positive, negative, or not at all, between the variables. For example, if we wanted to reanalyze whether the temperature during the production process affects the number of defects in products, we could use a scatter diagram to observe any trend. If we see that defects increase with higher temperatures, we might adjust the process programs to reduce those defects. Next is the control charts. Control charts are statistical tools to monitor a process over time to determine if it's under control or if there are abnormal variations that need to be corrected. These charts have a central line representing the process average and two lines that define the upper and lower control limits. If the process stays within those limits, we can say that it's under control. However, if we observe points outside the limits, we need to investigate and correct the causes of those variations. This tool is essential for maintaining process stability in production. Flowchart. A flowchart is a graphical representation that details every step of a process. It helps visualize the sequence of activities and defect bottlenecks, redundancies, and activities that do not add value to the process. An example of using this tool is in analyzing an assembly process where we can identify unnecessary or poorly structured steps causing delays or defects in the final product. Simplifying the workflow through this tool can improve both efficiency and quality. In summary, the 7 quality tools are fundamental for any organization seeking to improve its processes and products. Although these are simple tools, their impact on the efficiency and effectiveness of production system is enormous. They help us better understand our processes, identify root causes of problems, and make improvements that generate lasting benefits. As we've seen from the Pareto diagram, which help us focus our efforts on the most critical issues, to the flowchart, which lets us visualize each step of the process, each of these tools has its own role in quality control. It's not about applying them all at once, but about selecting the right tool depending on the problem or situation to be solved. I encourage the the engineers to explore these tools in your own work environment and see how they can make a significant difference in the quality of a product and services. Thank you for your attention. This is Alejandra. I'm a student, and this was my evidence.